Let's find the exact sine value of an angle that's not one of our standard angles. We're going to use 105 degrees equal to 135 degrees minus 30 to find the exact value of the sine of 105 degrees. And the way we'll do this is write sine of 105 as the sine of the quantity 135 degrees minus 30 degrees. Now the 135 and the 30 are more standard angles as opposed to the 105. And this obviously sets up well for the difference formula for sine. So we can write this as the sine of 135 degrees times the cosine of 30 degrees minus the cosine of 135 degrees times the sine of 30 degrees. Now we're going to use our reference triangles. Note that 135 is in quadrant 2, and we have a reference angle of 45 degrees. We're going to use that for a couple of our values. And we have our 30-degree angle, which is in quadrant 1. So we have our standard triangles that we can use. So the sine of 135, we're going to go to the left triangle. That is equal to 1 over square root of 2. Then we'll take that times the cosine of 30, which is the adjacent over the hypotenuse, square root of 3, all over 2, minus, now carefully, the cosine of 135 degrees is equal to a negative. So make sure you get the minus and negative here, 1 over square root of 2. And then you can take that times the sine of 30, which for our problem is 1/2. And again, using our base triangles here. So let's simplify now. Once we rationalize this, we're going to end up with the square root of 6 all over 2 plus the square root of 2 all over 4. I'm going to give it some space there. So square root of 4, this is 4 right here. We have square root of 4. Once we add those through, we end up with the square root of 6 plus the square root of 2 all over 4. And this is the exact value for the sine of 105 degrees.